Hello everyone, this is Chandrasekhar here. Welcome to my Zero to Hero Kubernetes session. In our last session, we have installed Kubernetes. But here is the big question. What exactly did we install? Did we install Kubernetes as a software? Did we install Kubernetes as collection of services? Or is it some sort of database? We are going to understand that part today. I have seen many people, they just install Kubernetes, they do the setup of Kubernetes and start executing kubectl command without understanding what happens in the background. So today we are going to unfold everything. Today we will try to understand everything from very scratch. The first thing which we need to understand is we have installed kubectl, which is the command line to interact with Kubernetes cluster. We have installed that in our last session. To understand if kubectl is installed or not, let's execute the command kubectl version. As I install, I get some output. We'll understand this output even in huge detail in our upcoming discussions. But we got some output. So if you get some output after executing this kubectl version command, just understand that kubectl is installed. And it is going to help you to communicate with Kubernetes cluster going forward. Another thing is to test if kubectl is actually giving you some information about cluster, about your Kubernetes cluster or not. To understand that, let's execute one more command. So as of now, you understood, okay, fine, kubectl is working. But is kubectl giving you some information about your Kubernetes cluster? For that, let's execute one command. Say kubectl cluster info. It says that yes, there is something which is Kubernetes, and the control plane is running on this IP. This IP is nothing but my homenet IP, my local IP, and code DNS is running, and this is giving you some information that basically says, okay, fine, you have one Kubernetes cluster setup already present in your machine, which for which I'm giving you information. So now what kubectl is doing? So kubectl, in very simple words, which I can explain you, is kubectl is nothing but, if you have to break kubectl into two different parts, so kubectl is nothing but the combination of kube plus ctl, isn't it? It's the combination of kube plus ctl. Kube stands for Kubernetes, short form is KTS, and CTL stands for control. So a software which is used to control Kubernetes setup is nothing but kubectl. That is what it is. Like we use remote control to control TV, to control multiple channels in your television. Same thing even kubectl is going to do for you. Like the way you saw, when I executed some command, it was giving me some information about my Kubernetes cluster. Another thing which you saw here when I executed this cluster info command is it says Kubernetes control plane. Now it is the time you should understand two very important thing about Kubernetes. What is control plane? So whenever we create Kubernetes cluster is having two parts. So if I talk about Kubernetes cluster, then this cluster is divided into two parts. One is control plane and another is data plane. Another important part is data plane. If you are executing, if you are using Kubernetes, which is hosted on multiple cloud platforms, nowadays almost all the cloud vendors offers Kubernetes support. If you're using AWS as the cloud support, then you do have EKS. If you're using Azure, it's AKS. If you're using Google, it's GKE. We'll talk about this also in our upcoming discussions. I'll explain you in huge detail which cloud vendor offers which software, uh, which is supporting Kubernetes. I'll explain you that also. No worries about that. For now, let's understand Kubernetes cluster. So Kubernetes cluster is divided into two parts, control plane and data plane. So what is control plane? Control plane, like the name says, is something which is controlling everything what you're doing in Kubernetes cluster. For example, think about a company. In a company, there is a CEO, definitely boss, super boss, boss of everyone. So in a company, there is a CEO, and this CEO makes all the decisions. So in a company, there will be CEO, and there will be multiple managers. there will be workers, multiple entities, multiple verticals will be there. So who is the decision maker here? CEO is the decision maker. Similarly, in case of Kubernetes cluster, all the decision is made by control plane only. In Kubernetes cluster also, there will be control plane, data plane, and there will be couple of other components which is a part of control plane and data plane. All the decisions are made by control plane only. So what a control plane does? Control plane makes decision. This decision is passed to data plane. This data plane hosts all the worker nodes, and within this worker node, I will have pods and applications running. Everything will be present in this. So everything will be controlled by control plane only. So I can say the control plane is like the brain of Kubernetes cluster. It makes all the decision. Where should a pod run, how application should be exposed to end users, all the decision is taken by control plane only. And what the data plane does, data plane hosts all the worker nodes. Data plane is something which is going to execute all the instruction. For example, if you have to run the container, how much CPU is getting consumed with the execution of those containers, how much memory is getting consumed with the execution of containers, how to serve users, everything will be done by worker nodes only. Like the way CEO makes decisions, workers do the work. Similarly, control plane makes decision and worker node or data plane runs application within it. This is what it does. Now, let's try to understand how those node looks like. In order to get all the nodes which is present in my cluster, I'll execute one kubectl command, which is kubectl get nodes. What it says, how many nodes are present in my cluster? My cluster is is formed of how many total number of nodes I will get by executing this kubectl get nodes command. Now it gives me the name of my cluster, status, role of the node, and so many things. If I want to know more details about the node, the command is kubectl get nodes hyphen o wide. You see the detailed output you will get. You will get the version of Kubernetes cluster, which is the latest one, which is 1.35. You do have the internal IP, operating system of your node, everything is present. So where I'm going with this output, I'm trying to explain you what actually a node is. So with this command, you can understand that it's showing that node is something which is formed of this operating system Debian. So that basically means node is nothing but it's just like a server. So node is nothing but it's just like a server where all your applications will run. It is this output is giving you name, node name, status, so many different things it's giving you, internal IP, everything, all the details it's giving you. Everything belongs to a node and this node is like a server. And there could be more than one server also. As of now, we do have only one server, but going forward, we will see how how a cluster can comprise of, can be formed out of multiple nodes. We'll have one control plane and multiple nodes which will be a part of our data plane also. That will also be there. So now we do have, let's think it in this way. We do have nodes. Nodes are hosting the application, but will there be only one application running in cluster at a time? No. There can be huge list of applications which can run at a time. For example, think of a big tower. In that big tower, there can be multiple apartments, and in those apartments there will be separate families, separate individuals who will be living at any point of time. Now, in order to isolate, in order to give personal space to each family, each individual in that apartment, there are walls which segregates the boundary, which segregates the resource utilization for each individual, for each family. Similar to that, in Kubernetes cluster, which is formed of these many nodes, there is some boundary. That boundary restricts the usage of resources by all the application which is hosted on these clusters. And that boundary is known as namespace. So if the Kubernetes cluster is formed of multiple nodes, then the boundary which is created in those node is called namespace. It is a virtual boundary. Consider it as a virtual boundary. And this virtual boundary is going to segregate resources which can be allocated to application. And those resources could be anything. Those resources could be memory, those resources could be CPU, and many other components which could be a part of the operating system could be segregated with the use of these namespaces. So as we installed Kubernetes, it gave me a default namespace. There is a kubectl command to list down all the namespace, which is kubectl get ns. As I have executed this command, you can see it gave me a list of namespaces which is already present in my Kubernetes cluster. Now, there is a namespace. As of now, let's focus on only one namespace, which is kube system. So kube system is the namespace which is going to host, within which a number of system pods will be created. So system pods will be those pods which is very much needed for cluster to function properly. So now let's execute command to just list all the pod which is present in kube system namespace. So as I executed this command, what I can see, it is going to list down all the pod which is present in kube system namespace. So what is pod? I'll explain what is pod in just few minutes. Please bear with me. So now kubectl get pods gives me, along with the parameter -n in kube system, all the pod which is present in kube system namespace. Now it gave me so many things. Let's try to understand each of these components, and with this I'll explain you a very simple diagram for you. So when I say control plane will consist of, and this is the architecture of Kubernetes also. This you can see is the architecture of Kubernetes. This control plane will contain something to which I call as API server. This will contain etcd, etcd. This will contain controller manager, controller manager. Also, this will contain something to which we call as scheduler. So API server, as you can see, is at the center of this hub. API server, and if I go to this output, I can see something is there with API server also. Kube API server is a separate pod which is present in kube system namespace. So now this API server is like the receptionist of Kubernetes. So for example, if you are going to any office, you are not going to meet CEO directly, are you? You are not going to meet CEO, right? You are going to talk to receptionist first, and receptionist will route you to the right direction if you have proper approvals. Similarly, if you think about going to somewhere, going to some hospital, if you are a patient or if you are related to a patient and you are visiting to a hospital, then the first place which you are going to halt is reception. In the reception, you will talk to receptionist, and this receptionist will route you to the right direction. Similar to that, the receptionist for Kubernetes is Kube API server. So all the traffic, all the request, all the queries first falls onto Kube API server only, and Kube API server routes it to the right direction. What is the ultimate goal with us? The ultimate goal is to host an application, that application which will be consumed by end users. So the traffic is first coming onto the API server. The API server is going to read the traffic, understand the traffic, and then going to act on the traffic. But will API server work alone? Can receptionist work alone? No. Receptionist cannot work alone. The receptionist, what they do, they will check first in the record of their system, do you have proper approvals? So somewhere in the memory, information about visitor should be present. if you are going to any office, if you are going to any hospital. Similar thing happens in Kubernetes also. In Kubernetes, this receptionist API server is going to check in Kubernetes database if some information is present, and the database of Kubernetes is this part is etcd. So etcd is known as the database of Kubernetes. All the information about pod, about applications, everything is present in etcd only. So consider etcd is like a Google Drive. All the information is stored in etcd only. If the etcd is lost, there will be no memory, no state, no cluster information. Everything will be gone if the etcd is gone. Next very important part is scheduler. So now consider that you want to create two pods, and those two pods has to be created there in your data plane in your worker node, which will host some application. Now API server has checked in etcd database, do I have already two pod present? If the etcd says no, I don't have those two pod present, then API server will go to scheduler and will say, okay, scheduler, please create two pods. Now it is the responsibility of scheduler to create those pods. Scheduler is acting like a dispatcher. For example, Rapido dispatcher. We all use Rapido. In order to do that, what we do, we open Rapido app and we try to book the vehicle, and as we book the vehicle reaches to my doorstep. This is the job of the dispatcher. Same thing is done by scheduler also. Scheduler acts as a dispatcher. So now with this scheduler will further communicate with data plane and will create some pod for me. Another very important thing is controller manager. What this controller manager does, controller manager ensures that your desired number of pod is equals to actual number of pod. So the main job of controller manager is to ensure desired is equals to actuals. For example, if you wanted to create two pod, but at a time only one pod is present, then controller manager is going to check that thing. So for example, controller manager is like a manager of a restaurant. For a owner says that he needs five waiter. He or she needs five waiters, and but the reality is only four waiters are present. It's the responsibility of manager to ensure that the requirement of owner is fulfilled properly. So this is what the component of control plane is. So to summarize, control plane consists of etcd. This is the brain of control plane. It is like a receptionist who takes all the information, all the query lands first on API server only. From API server, it goes to etcd. etcd is the database of Kubernetes cluster. From etcd, the instruction reaches to scheduler. Say in case if I have to create two pod, three pod, all those information reaches to scheduler. From scheduler, the task is taken over by controller manager. Controller manager ensures that the required number of pod are present at this point of time. So in today's session, I have completed control plane as a topic. In my next session, I'll talk about data plane and more topics about Kubernetes cluster. If I'll talk more, the session will be lengthy. That is the reason I'll break into two smaller sessions. In my next session, I'll talk explicitly about data plane and furthermore about Kubernetes components. Thank you everyone for watching my this session. If you did not subscribe my channel, please subscribe it so that you can remain updated on my all upcoming videos. If you did not share my videos to others who actually need this session, please share it so that they can take benefit of this session. Thank you everyone for watching my session again.